Hi, I am Divya. This is my implementation of the AI customer support agent. The application is built with Next.js, TypeScript, Grok, MySQL, and Tailwind CSS. The main goal is to let an AI agent handle e-commerce refund requests while keeping the actual refund policy controlled by the backend. First, I will demonstrate the application with a successful refund and a policy edge case. Then I will walk through the architecture, tool orchestration, and the agent observability dashboard. So, demo number 1, a successful refund. Like the customer will make refund in a natural language. For example, I want okay. So this is an already existing order for which I am requesting a refund. The LLM agent will receive this request through a simple Next.js API. So yeah, here the agent first retrieves the order and then checks the refund policy. Because the order satisfies the amount refund requirements, the policy engine will return an approved decision, which leads to the successful approval of a refund for the specified order. So as now we have initiated an sort of an event by requesting a refund, the super user of this system will have a live log. As you can see, now we requested a refund which was successfully approved. So we see the event type and the output given by the LLM. So which brings us to our next scenario, which will be a sort of an edge case. The one which I would like to focus is, like, as we can see just now we are refunded ORD 001, which means it's already approved and processed. So requesting once again will lead into a failure. So as you can see, already an order has been refunded. So we just can't refund an order twice. And the LLM and the database have written the appropriate responses over here. The important part here is LLM doesn't decide to approve the refund. It is first checked if the order is actually eligible or not against the backend policy, and then the decision is returned. So as you can see, the admin dashboard has successfully logged the latest event into the system. Now this is the API which fires when user starts to chat with the support chatbot. This gives the LLM interaction and database operations on the server rather than exposing them to the browser. So when the API calls to the agent starts running. In this, we first give a massive amount of context to the system regarding our backend and our possible requirements for the customer support ecosystem, and also some real life validations as per our requirements. So as you can see here, we enter the LLM model. Every call over here is logged. The agent starts to run at first, and here the agent tries to execute a tool, but if our current customer request isn't categorizing in any of the scenarios which are drafted at our backend policy, then it leads to error. But a agent looping call mechanism is applied over here with a specific call limit so that it doesn't go into infinite calling. These are the tools exposed to the LLM. They describe what operations the agent is allowed to request. So like the very first one, get information about the customer, and yeah, like these give the LLM an idea about which policy method it's going to call and what it's going to be about. So there's get in customer, get order, get refund policy. The important separation here is that LLM doesn't directly access MySQL. It requests a tool and then the TypeScript executes that tool. So the get order over here is the function name through which the actual tool will be called in the execute tool module. And this is the logger file which will help us to construct the data for the admin dashboard for the super users. Every important event in this system is logged, including user message, tool calls, tool results, errors and completions. So the previous message which we tried is over here. So the overall architecture is the customer sends a request through the Next.js UI. The API passes it to the Grok powered agent, and the agent uses control backend tools to access MySQL and evaluate the refund policy. And the resulting execution is logged for observability. The key decision was keeping LLM responsible for natural language understanding while keeping the actual refund decision in the backend logic. That's the completed implementation. Thank you.